Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 763, partition labels. This question is based on HashTable concept and we'll be using greedy approach here. Also, this question has been asked in a lot of tier 1 companies like Amazon, Google, LinkedIn, Meta, Microsoft. Let's have a look on the problem statement. Here we are given a string S and we want to partition the string into as many parts as possible. As many parts as possible so that each letter appears in at most one part. This is like our operation we have to do, and S is our input. We'll have a look on the other things later. Firstly, what is given to us? We are given a string S, and from that S string we have to do the partition of the string. Let's say if I just cut it here, so this is the first partition, second partition, or if I just partition like this, so this is the first partition, second partition, third partition. This is partitioning of the string, and we have to keep in mind that if we are partitioning it, that any character, if that character is appearing in one partition, it should not be appearing in any other partition. Let's say if I just check A is present in this partition and it is also present in this partition as well. So this partition is not valid. It means we have to keep all the occurrences of A in a single partition. If I try to go like this, all the occurrences of A are in this partition, but here B caused the trouble. B is present in this partition and is this partition as well. So this is also not a valid partition. If I go like this, this is one partition A, B, and the second partition is CC. Here, if we just try to match it with the problem statement, as many parts as possible so that each letter appears in at most one part. So every letter, whether be it C or B or if it is A, every letter is appearing in only in what partition. So these two partitions we can make. If I don't do any partition, let's say if I do this like this and I call this whole string as a partition, here also every letter is appearing in one partition, in a single partition. But here in our problem we are also expected to have the maximum number of partitions possible, as many parts as possible. It means this is a partition, proper partition, but this is a valid partition, but this is not the maximum partition number. So operation is partition the string such that every character appears at most one partition. Every character should be the part of at most one partition, and along with that we have to do the maximization on the partitions. Try to partition as many as possible. So after one partition, if I try to do the partition again, if I try partition like this, the C is going to trouble. If I partition like this, B is going to trouble. So this is the case. So now this was our problem statement. So for this string, smaller string, we'll get 2 as the answer. And what we have to return? Note that the partition is done so that after concatenating, okay, this is something like we have to cut slices, not in some random order. And what is the return type? Return a list of integers representing the size of these parts. So these two are the parts for this string and the size of these parts are 4, 2. So this 4, 2 is something we have to return. Now we have to build the approach. So this is the problem statement. This was the problem statement, and I hope you understood the problem statement, that what is given to us, we will be given a string, and from this string we have to do some partitions in such a way the partition should be maximum in number. Do the maximization, maximum number of partition we have to use. Along with that, every character should be the part of only one partition. Character should not appear in more than one partition. Okay, so if I try to do the partition, if I start with B, I'm picking B. If I just cut here, this B is going to cause the trouble. If I cut it here, this B is still causing trouble because B is present. So from this we are getting an idea. If we want to do the partition that is going to include some character. If my first partition is going to include B, my first partition should include all the occurrences of B. So B is first occurrence of B is this, last occurrence of B is this. If there was one B here as well, so we should have included this and this in a single partition. But this is the case. So we have to include B. But meanwhile, O has come. So include the last occurrence of O as well. So whenever a character we are going to include in our partition, we have to include all the occurrences of that character. All the occurrences of B has a last occurrence on this. O has only one occurrence, so B has only one occurrence. Nice. So this partition is valid. Now we have to check H. If I just partition from here, H is not coming at any other place. So if any character is already unique in string, so we can have a partition of size 1. Nice, because we want to maximize the partitions. Now A is the next character. A is only coming once, so just do the partition. S is also coming one, do the partition. Now we have come to P. P has a first occurrence at this, but P has a last occurrence at this. It means we have to at least include these values. But along with this, when I am coming at E is also having this value. So last occurrence of E also we have to include. So whenever a character is, whenever I am trying to include the character CH, what I should know is, I should know the last occurrence of CH or last index of character, because whenever I include, let's say I included P, I am 100% sure that at least my current partition will go to this P, last occurrence wala P. This will be the partition and this R will remain the partition. So in the first partition we have 3, then one size partition, then one size partition, then 1, 2, 3, 4, 5 size partition, and then one size partition. So these are the sizes of partitions that we have made. Okay, so yeah, this is something we have to do by coding, by writing the code, because for the strings of size less than 10 we can just do the partitioning by looking at it. But for the very longer strings, we have to write code, or we have to write our algorithm. Now we have to prepare the algorithm. See, let's say for every part of algorithm, every time there is some kind of initialization. For this, initialization is 0. Let's say I equal to 0. I'm going to iterate over the string from starting to ending, and for every iteration, let's say we are working on the current partition, and for the current partition, let me check. Partition start is 0, and what is the partition end? Let's call it 0 for now, because when we are going to process the first character, I will have a look. Now we have to do the iteration starting from first character to last character, and I'm going to process my first partition. First partition is starting at 0 and ending at 0. When I am done partitioning the first character, I should know the last occurrence of that character. Okay, so there is one prerequisite I am getting, that whatever the character is there, I should know the last index it is present. S consists of only lowercase English letter. If it is only lowercase English letter, I can take an array of size 26 to store the index of the last occurrence. Okay, and if you have to prepare an array to store the index of the last occurrence, you just need to do one iteration over the string, and whenever the index is coming, just put, let's say, last index of character minus a is equal to I for the loop, right? So this is the first step. Step 1 is capture last index of every character. Now when it is the time of doing the processing, for the pre-processing, partitioning starting at index 0, and at index 0 character is b, so it means the last occurrence of b should also be included in this partition. So our partition tentatively will go till this position. Okay, so it means that at least we have to keep on capturing element till this partition. So first partition we can't reduce it further. We might have to extend it because there are other characters as well. So increment I, and then O. O is the character. Now O is the character. So if there is any other occurrence of O, we also have to include that as well. But if there is no other occurrence of O, like O has a last occurrence this, there is nothing to do. In this case, our tentative partition end cannot be reduced. It can only be extended. So when I'm coming at index O, so partition end will be updated with 2 when we check the last occurrence of P. Partition end is 2. Okay, my I is at 1. I is at 1 and partition is at 2. When my I will be at 2, partition end will also be 2. Okay, now you have to think a bit. I is 2 and partition end is 2. It means we are okay to partition at this after this index. We are okay to partition after this index. It means that this partition will be valid. And what will be the size of this partition? We have partition start and partition end. 2 minus 0 plus 1, which is 3. So in the answer list, we can add 3. Now my index is at this. Okay, now we have done the partition and we are ready to move to the next partition. For the next partition, my P start will be I plus 1. So P start will be at index 3. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. My P start will be at 3 and P end will be updated when I will come here. Okay. Now my index is at H. What is the last occurrence of H? Last occurrence of H is 3. So P end will be maximum of 2 and 3. So it will be 3. Okay. But my I is also 3. I and partition end is same. If I and partition end is same, it means we can easily partition from here. There is no need to go further. And then increment I. Incrementing I means I is coming to 4 and the next partition will be starting from 4 and the next partition end will be current element is A. What is the last occurrence of A? Last occurrence of A is also 4 and partition end is 3. 3 and 4, whatever is the maximum, just that will be my partition end. And index is also updated because I am at 4. Now still index I and partition end is same. So partition from here and now increment the index. Increment the index to 5. So 5 is S. What is the last position of S? Last position is also 5. Partition end will be 5. Partition start, whenever we are capturing a partition, we have to initialize partition start with I plus 1. The partition I is I plus 1 if we are capturing it. So the next partition will be at this. And now what is the value of I and what is the value of P start and what is the value of P end? So partition is ending. So I should be incremented to 6. And P start should be incremented to 6. P end will have a look. Initially the value was 5 from the previous iteration. So now what is the last position of P? See, the last position of P is 9. So at least this partition should go till 9. Okay, so move ahead. The next value of I is 7. What is the last position of 7? E. Last position of E is 10. The partition should go at least 10. And the next value is P. It is last position is 9, so it will remain 10. Index will become 8. The next item is P. P will go till 9. P has last position is 9, and now partition ID is already 10, so it will remain 10. At this position, last index of E is 10. Partition end is already 10, and my index is 10. Index and partition end is same, so there is one more partition scope. And when I'm coming to here at R, the index is 11 and the last position of R is 11. There is one more partition, so whenever they are same, just capture it. Capture the P and P start -1. So I have forgot to update the P start, but yeah, P start will also be updated to 11 in this case, because when we capture a partition, we just increment it. Okay, now we have to prepare the algorithm. The algorithm should be initialization state is, what is the initialization state? I should be 0, P start should be 0, P end should be 0, while I is less than n. While I is less than n, partition and is equal to maximum of current value. Maximum of current value and the last index of current character. Last index of current character. Current character means character at I. So this is the partition end. And after the partition end, if I is equal to partition end, if I becomes equal to partition end, it means we have encountered the proper partition, and we can cut the partition and initialize the state for the next partition. If this is the case, just capture it. Capture it means answer dot add partition end minus partition start plus 1, and partition start is equal to I plus 1. This is the starting position for the next partition. Okay, so this is the case if they are not matching. If they are matching, in that case, do we have to do anything? If they are, like, if I and partition end are not matching, in that case I did this. Apart from that, I don't have to do anything. I just increment this. So this is the algorithm, and here in the algorithm I require last index, and this character I think I can just do the s dot character at I. So what is this last index? So whatever is the string I'm going to use. Let's say I pick ABC, AB, ABCC, A, B, A, B, C, C. See here, this is the string given to us, and we have to capture the last index of every character. Characters will go from 0 to 26 length, that is 25 is the last index. This will be mapped to A, mapped to B, mapped to Z. So whenever I'm encountering A, whatever is the index, I'm going to capture that index in this table. So this is like hash table we have formed by just doing one iteration, and after that one more iteration I'm doing. So in short, in order of n time I'm able to do it. What is the space? It's a constant space because only 26 size character we have taken. Apart from that, there is an answer list I'm also going to use, but that is something is requested from the problem statement, so that is not considered as an auxiliary space. So this is a time space complexity. Now let's write the code. First of all, let me capture the length of the string, and apart from that I need to capture the last index of every single character, and the characters will be from the lowercase English letter, so it will be 26 in number. Let's say I call it li, last index, new integer of size 26. I have to go through every single character and I need to capture the index, so that's why I'm writing for loop. I less than n, I plus plus last index of what character? S dot character at I. Corresponding index is this. Last index of this character will be stored at this position in the 26 size array, and that value will be I from the list. Okay, now we have captured the last index, and here we have to do the initialization. My I will be 0 and my partition start will be 0, partition end will be 0, and while I is less than n. While I is less than n, first of all I need to process the I. Partition end will be equal to math.max. Let's say we have captured the partition end already, that is bigger than the current partition end. And now what is the last index of current character? Current character last index. So last index of current character is present at this index. What is this character? S dot char at I minus a. So this is the partition end, and we are going to capture it if I has become equal to partition end. Then capture this partition means answer dot add partition end minus I plus 1. Partition end minus partition start. Partition end minus partition start plus 1. And what is this answer? Answer is going to be the list of integer. Answer is equal to new array list. This is something I will be returning from my function, and here in the end return answer. Now we have captured the partition. Once we have captured the partition, get ready to capture the next partition. Next partition start is going to be I plus 1, otherwise increment I. I is definitely going to be incremented in every iteration. So my first step is capturing the last index and then using the last index to see till what value I need to partition for my current character. So this is the value. Okay, let me test over sample test cases if it is working fine or not. It's working fine. I'm submitting the problem. It got submitted successfully. I hope you understood the approach. Thank you guys. Bye bye. In case you get any doubt, you can have a discussion below in the comment section.